Hello everybody, welcome back. Now we're going to do method 2. I'm going to show it on Desmos and of course the graphing technology. It says solving when not in standard form. So when you are given an equation, it looks like this. This is the easiest way to solve this. So it's a step-by-step process and it's very simple. So what we're going to do is we're going to set the left-hand side of the equation right here equal to 3x squared minus 6x plus 5. We're going to set the second side, the right-hand side, equal to y2 on the graphic technology. We're going to graph the two functions, and they're going to intersect in two locations. We know that because of what we received in the last question. And the x values we end up with are going to be the same as what we did before, but it's the intersection values. And those are going to be the roots. It's phenomenal. Just want to make a little correction from the last video. Here I had 3.56. It should be 3.58, which actually even brings it closer. But again, when you round, you're still getting, even at the 100th place, you're still getting the same value, right? So approximate to when you do a verification. Okay, and again, that's because these were rounded. So I'm going to show that on the calculator. So what we're going to do is we go y1, we set that equal to the first equation, and then we take and write it again, and we call it y2 this time, and I'll do this one, the one in the blue and one in the red, not that it makes a difference. Alright, and we do the second side. Okay, I've got all that. So we do left hand side for the first equation, or function, I guess I should say function because y equals, and y2 equal to the second function from the equation. And the intersection of these two will be your answer. It's beautiful. So we'll go to our graphing technology. Again, you can clear this again if you wish. Remember, second function plus 7, 1, 2. RAM cleared. I'm going to put the first equation at y1, and that was equal to the left-hand side, which was 3x squared minus 6x plus 5. And my second equation, y2, was equal to the right-hand side. And again, you don't even got to use the distributive property. Just put it in exactly as you see it. 2x bracket 4 minus x, close bracket. Graph them. You're going to see that you have a graph here, two intersection points. Now, if you want to make this a little bigger, I don't need a lot of this and this. So I'm going to go to my window, and I'm going to make that negative 2, not subtract 2. Negative 2 is important. I'll make that 4, and it just spreads it out a bit. Not necessary. Again, if you want to get rid of some of the negative y, you can. Hit zoom, and I'll just make it negative 4. Again, I'm just picking random numbers just so I'm spreading it out, right? Perfect. So remember, this is 1, 2, 3, 4. And these are going up by 1s, right? Okay. So we'll find the intersection points. So second function calc, intersection. First curve is blue. Bring it close to the point you want to intersect. Once you hit enter, it'll jump to the next closest curve. Hit, and there's only 2 obviously. Hit enter for the third and final time, and you'll notice you're getting the same x value. You're not concerned about the y value, which if you look, when you verified, that is the y value, which is kind of interesting. That's the y value you should have got when you verified. Neat. Talk about that, why that is in a little bit, but what we're concerned about here now is the x value. So I'll take a picture of that for my diagram. Okay. A little bit smaller. Okay, and again, you can do that again. I'll do that again just to have the second curve. Okay, so I'll go back to my graphic technology. Do second function calc. We're going to get the intersection point again. So fifth, or just hit 5, right? Fifth option. You're going with your right cursor until you get up to the second intersection point. Hit enter. It'll jump to the second curve. Just hit enter again. Hit enter for the third and final time, and it is 2.38. Okay, which is kind of neat. All right, and if we did the verification on this point, both sides would equal 7.7, which is kind of cool. All right, so there we are. Graph that one for you as well. There we go. And there's the two intersection points. Remember, you're concerned with the x values. That is what you want to look at, these two x values. Exact same as the ones we had here before. They're there. Right? Now again, the y values are different because we did it a different method. This is using x-intercepts to find the zeros. This was using intersection points, which would give you different y values. But you're just concerned about the x values, as I pointed out. Find the x values. And there's the solutions. Let's do it in my, so that's finding x values and the x points using TI-83 or TI-84 technology. Okay, and that we'll call that method 2A. All right, method 2A. Let's do method 2B. Method 2B, find the x values of the intersection point using desmos.com, which we love. Okay, so we'll do that in the same thing. We'll put those equations, so I can copy these right over to Desmos. Copy. Right, there's a Desmos program from our last graph. Just plug it in there. There's the first equation. Okay, second equation, and you don't have to call it y1 here. You can just call it y. And here you can do the same thing, y. And you can call them, it doesn't matter, but you can call them whatever you want. I use y and x usually. 2x bracket, 4 minus x, I think it was. Alright, and to be consistent with the colors, not that we have to. We do the red for that one, so I'll make this one red. I'll make this one blue. Not that it matters. Okay, so we have our graph here. Okay. And intersection points is what we were concerned about here. I'll take a picture, bring it over. Okay. There you go. So just click on the points on Desmos, like I've shown you before. And again, yeah, much quicker than using the graphing technology. As you can see, it's quite obvious. So to answer the question, and again, those were the verification points for which is kind of cool. If you verify your answer with the original equation, this is what you get back, which is kind of neat on each side. So 0.42 would give you that, which I showed you up here. There's the connection. Which is, now again, they're close because these were rounded. This value here is exact that you see here because they weren't rounded. So again, to answer the question, the roots. And in this way, it's actually called the intersection points, right? The x values of intersection points. And that's just for method 2. Remember that. Are there. Same ones, right? X is equal to, X is equal to. All right? So I'm going to say X is equal to 0.42 and X is equal to 2.38. So people are saying, how can the x be two different things? Once you get into quadratics, you can have up to 2, right? So I know that is new terminology. And again, we're going to get there. We're not there yet, but we will be very soon. Okay? So those are the solutions, right? Yeah, so maybe I won't use the roots. I think a better thing will be the solutions there. Because that's just the method. So I don't like how I said that. So I'm going to say the solutions. Okay? Or x equals x equals. We use roots there, right? But remember, it's just the x values of the intersection points. So that's it for section 7.3. There's 8 questions there on page 379 you can work on. Again, try both methods. Desmos I know is a lot easier, but the graphic technology is what we're using at this point. But yeah, that's it. So lots of different methods how to find that, and We're going to show it algebraically too, but we're not there yet. Like once we get some skills, we do the graphing first, which I think is kind of interesting. Some people say do the algebra first, but then you might get frustrated. But I think it's neat to see the graphs at the beginning, so I can understand how they're doing in the book order. So I do see the benefits as well. All right, so like I said, just look at the questions there. You can try some of those. Homework, page 379, 1 through 8. Thanks for watching, and we'll talk again soon.